The landscape of northeast Wales is just breathtaking. But here you'll also find the biggest manufacturing site in Britain.
For me, its beauty lies in its industry. Just look at this. It's just stunning what's produced here.
For over 7 decades, Flintshire has been at the centre of Britain's aerospace industry. And some of the planes built here even broke world records. The world is watching North Wales again, as the engineers here revolutionise air travel as we know it. They create wings for some of the largest aeroplanes to fly in our skies. And their latest A350 has a groundbreaking new design. To find out how they're doing it, I'll be joining the team assembling one of these wings, uncovering the surprising secrets of their engineering along the way.
Stunning, just stunning.
And finally, the ultimate test. I'll fly on these Welsh wings to discover whether their innovative design is helping to create the quietest and greenest commercial flight ever.
Do you really like flying this plane?
Oh, yes.
Do you?
Number 242, Charlie Victor, Hunter. Good morning again. Join crosswind and report left-hand downwind runway 22, the QNH and the QFE 1012.
I love the North Wales coast. Just look at that view. I grew up in Prestatyn, and I used to sunbathe on that beach down there and look up and see the aeroplanes coming in and out of Liverpool Airport and think, one day I want to fly a plane. It's taken me a long time to get there, but now, here I am. Hello, Prestatyn.
All that I want is a pair of wings to fly.
On radar, November 242, Charlie Victor. We are 11 miles to the northwest. Request joining instructions.
I've recently qualified as a pilot, fulfilling my childhood dream. And this is the first time I've ever flown low over my home patch.
What I didn't realise when I was growing up is that North Wales is one of the hubs in the world for aeronautical engineering. And down there is where they build some of the best parts of aircraft in the world.
Airbus Broughton is located on a massive 750-acre site in Flintshire. Here they build wings and then transport them on this extraordinary plane to the south of France. Everything they do is on a gigantic scale. And their latest groundbreaking design is taking the aeronautical world by storm. My little plane isn't as big, but she's just as loved.
November 2, Charlie Victor, runway 22.
I'm flying in to find out how these brand new wings are setting a new benchmark standard for fuel efficiency.
You're parking on apron Bravo with the Beluga. So once runway vacated at Bravo, if you follow the marshal's instructions.
It's cutting-edge stuff. We may never fly in the same way again, and it could all be down to some Welsh wings.
Broughton is famous for building wings. The wings of an aeroplane are critical to how the plane flies, its handling and its fuel efficiency. And this year they're celebrating 75 years since production first began on this site. Today they're supplying some of the most popular airlines in the world, and that keeps around 6,000 Welsh workers busy. And I get to join them.
So you're the man in charge here.
Yeah, it's good to see you here. Welcome to Broughton. This is where we build A350 wings. The A350 is one of the most advanced aircraft in the world. It's made of advanced materials. 70% of the product is advanced materials, and 53% of that is carbon fibre composite.
Carbon fibre is a form of soft graphite, just like what's found in the centre of a pencil. It's mixed with plastic resin to make carbon fibre composite. It's tough, lightweight, but extremely flexible.
We're currently building 1 pair, 2 pairs per month, but by the end of this year we've got to get to 5 pairs per month.
Within a year?
That's a 5 times increase, that's correct. I understand you know a little bit about engineering, Carol.
Compared to you, about that much.
Would you like to join us?
I'd love it, I really would love it.
OK, great.
The moment has come for me to get hands-on experience in building one of these wings. This uniform reminds me of when I was a very junior engineer at the Denwick Power Station in Snowdonia. And of course we had the capped shoes or boots, the boiler suit or overalls, and the obligatory hard hat. Yes, sir. They call this the washing line, and you can see why. Except here, we don't have clothes hanging down. We have the skins or the covers of the wings. This is the top cover, and this one here is the much more curvy bottom skin. What's so remarkable about these is that they are the largest single pieces of carbon fibre composite ever made in the world. And that gives you some indication of just how revolutionary this place is.
Good afternoon, Station 82. So to start with, safety, okay, no near misses, no accidents.
It's the start of shift, and we're all lined up for the team briefing.
Some of us will be supporting MSN 25 removal from jig. Any issues? Right, thank you very much, guys. Have a nice afternoon.
Just take that with you.
My first job is to move this 2.5-ton carbon fibre top skin of the wing into the jig so we can work on it. To manoeuvre it around the factory, we're using a special vehicle known as the AGV.
Hi, Carol.
Hi,
Your turn to
Rusty.
shine today.
All right, then.
You're going to help us out?
Yeah,
Moving this
moving
panel?
moving the cover.
Going to move the cover today?
Is that for me?
Yep.
Hope it's the right size. I have got my certificate in
Good.
forklift truck driving. It's
Well,
not quite the same,
that's not
is
going to
it?
help us today.
So put this around my waist.
This is the
do I?
box. This is the dead arm box.
What does that mean?
My colleague's going to be driving.
What's a dead arm box mean?
Whatever. If there's a problem and we're
Yeah.
swinging and
Yeah.
we're coming to a bollard, if you think it's unsafe,
Yeah,
take your hand off that
yeah.
and the machine, AGV will
Just
stop,
cuts out.
cut out straight away.
And that's worth millions, isn't it?
I'd guess, I think possibly 1.1 million, 2.
Yeah.
So,
1, 2.
that's only.
It's only
It's
carbon
only money,
fibre,
isn't
eh?
it?
It's only money.
So, Eddie, good to go.
Right, I'm sticking with you, Ross.
Yeah.
This is brilliant. The way this
And this
moves.
is stuff. It's fantastic.
These wheels are incredible.
And I think it's roughly about £8,000 a wheel.
Is it really?
Yeah.
This is an extremely delicate manoeuvre, and you can feel the pressure. The team knows that one false move could cost a fortune.
Take your hand off now. It stops straight away. It's looking like possibly may have to move this
Move this.
frame.
This AGV not only manoeuvres, but it can also lift this heavy and expensive piece of wing.
You're going over the top.
First flight.
It's like, yeah.
Luckily, it has just enough reach to clear the frame. It's been designed by the Americans, is that right?
I think that's German. I think Kuka's
Say that again. What was it?
German. Stand board.
I know, yeah. The next stage in the manoeuvre is to lift this delicate topskin right up to the ceiling of the hangar and then across to the jig. The frame uses 103 vacuum suckers, just like the suckers to hold your cuddly toy in the car, but just a little bit more powerful. I feel as though I'm attached to this wing now, some kind of ethereal way.
Go on, Carol, give it a full whack.
Bit of welly.
Yeah, give it a bit
Go,
of welly.
baby, go! Woo. She doesn't swing as fast then,
No.
does she? She's good.
The quicker it's in the air, the safer.
But she's safe, tidy up
She's
there.
safe, she's not swinging, and she's happy to be drove in now with no problems. So I'm going to take it into the jig now.
Yeah, go on.
And then we're going to lock it down.
All right, I'll hold the papers.
Thank you.
While I leave Rossi with the tricky job of positioning the top skin, I'm going underneath to get my hands dirty and come face to face with those carbon fibre wings.
All right, boss, what we're going to do?
Basically, the machine comes in, drills all the level cover, but it can't get in this area because it clashes with cantilever.
The pressure is on me now to drill a perfect hole. The drill I'm using here is powerful, and to stop costly mistakes, it's completely automatic. Perfect. One down. Several thousand to go. Although I've got a sneaky feeling that someone's drilled some already.
That's it. Good hole.
Thank you very much.
Choosing carbon fibre composite over old-fashioned aluminium has meant huge changes for the workers here.
I mean, the thing is, for someone who's a passenger, what it's made of is so completely different, isn't it? The kind of the cleverness is hidden almost.
Yeah, it's
from the
so alien
passenger's
to
eye.
us, it's just metal. We've
Yeah.
worked with metal for so long, and now it's all of a sudden it's just a different.
It's like NASA.
It was like going from
like
the,
NASA
it's like
to
going
us.
from the cave to NASA.
It was.
We were like cavemen. Cavemen to astronauts in a week. So, yeah,
Failure is not an option.
Working with carbon fibre has completely changed how the wing can be shaped. The curve in this panel could mean cheaper fares for everyone, as it reduces fuel burn by 25%. To understand how, I'm going back to the basics of flight.
It's the wing that gives us lift. Now, I'm going to show you just with a little drawing about how it works. So I'm going to draw my wing here, and generally on a wing, the curvature on the top of the wing is greater than on the bottom, and there's a reason for that. So this is my airflow. So when a wing is moving through the air, you see that a dot on this bit of air coming over has to go all the way over the top of the wing. A similar dot just travels underneath, and then they meet up at the back and then on they go. Now, the thing is, when this one going over the top of the wing travels, it has to go faster than the bit of air on the bottom. So what you get is you have high pressure on the bottom, low static pressure on the top, and the high pressure pushes the wing upwards, and that is the force that we call lift. Or, when you're looking at an aeroplane, I call it magic.
It doesn't matter if it's a jumbo jet or a bumblebee. They each achieve lift in the same way.
Now, if you don't believe me, you can do this at home. Get a bit of paper, okay, static pressure the same, the weight of the paper is hanging down. When I blow across the top, the pressure on the top will reduce and we will have lift. You see?
But once in the air, the shape of the wing determines the way the aeroplane flies. The best way to demonstrate is with a bit of aeronautical origami.
I think you're a bit of a neater folder than me.
Oh, is that what it is? You're after speed.
And as a former fighter aircraft designer, Roy Scott knows all about it.
One of the main principles is the angle of the wing relative to the fuselage, to the body. So, for example, here